So rational inequalities are solved in basically the same way. We find those boundary points, the numbers on the number line, by setting the denominator equal to 0 and the numerator equal to 0. So let's do a couple examples. So in this problem, first of all, we still have to make it equal 0 or have 0 on one side. So we need to take this and subtract 1 from both sides. And then we need to do some work because we need to rewrite this 1. Now remember, 1 is the same as 5 over 5, 7 over 7. Anytime the top and the bottom are the same, it's 1. So I can write the bottom as x plus 1, and I do that because I want the denominators to match. But if I want it to equal 1, I have to have the same thing on top. And now I can do some simplifying because this minus has to go to both pieces. I'm going to write this as 1 fraction, x plus 1 on the bottom. So I'd have 2x minus 1 on the top. And I can simplify that to just be x minus 1 over x plus 1, and it's now greater than or equal to 0. So to find my number line points, I take this top, set it equal to 0, which gives me 1, and I take the denominator and set it equal to 0, which gives me negative 1. And those are the points I'm going to put on my number line. So let's say that this is my 1, and this was greater than or equal to, so I'm going to have a filled in dot at 1. Now here's my negative 1. Now here's the little weird part. The denominator of a fraction can never equal 0. So we can never, for the denominator, is always an open circle. So here I'm going to have an open circle. So that's how I'm going to use my number line when I go back to my original problem. So let me get this cleaned up and then we'll look at how we keep going. So now we still need to choose a number in each section. Let's start over here and let's choose x equals negative 2. So we go back to our original problem. And we're trying to see, is that a number greater than 1? Well, on the top I'd have negative 4, on the bottom I'd have negative 1, and negative 4 over 1 is 4. So that's a yes. That is bigger than 1. So I'd want to shade in this part right here. So the next thing I'll do is choose something in here, and let's say maybe 0, because 0 is nice to work with. So I'd have 2 times 0 over 0 plus 1. That gives me 0 over 1, which is just 0. And 0 is not bigger than 1, so I'd leave that part blank. And then finally, I'll choose a number over here. So let's say 2. So I'm going to stick 2 into my original problem. And I get 4 over 3, and 4 over 3, if you put that into your calculator, is 1.33333, but that is bigger than 1. So I'd want to shade this part right here. So now let me get this cleaned up and we'll look at how we write our interval notation. So as always, we read the graph from left to right. So first I get a negative infinity because of the negative arrow, and then negative 1. Now negative 1 is not included because denominators always have this open circle. And then I start at 1, and 1 is included because of the equal sign here, so it's a bracket, and then it goes on for forever, which is infinity. Put a u between them, and there's our answer. Now I know this example is not in your notes, but let's write it down. X plus 1 over x plus 5 is less than 2. We'll write it down so that we have one more example to look at here. So again, we need to start with moving that 2 to the other side. So we have minus 2. And then we need to remember this is 2 over 1. We have to have a common denominator, so we need an x plus 5 on the bottom. So in order to get an x plus 5 on the bottom, we need to multiply by x plus 5. And if we do that on the bottom, we have to do it on the top as well. So I'm going to copy this x plus 1 and the x plus 5. I'm going to use that negative to distribute in here with the 2. So I'd have minus 2x minus 10. And I'm still keeping the x plus 5 on the bottom. So now, because these now have a common denominator, there'd really be a plus sign in between there now, I can put them together as one fraction. So I'd have x plus 1 minus 2x minus 10. And if I combine like terms, I get negative x minus 9 over x plus 5. And now I'm ready to set the top equal to 0. So I get negative x is equal to 9. Move the negative to the other side, I get x is equal to negative 9. I'll do the same thing with the bottom. X plus 5 is equal to 0. X equals negative 5. Remember, the denominator always has an open circle. So on my number line, I'm going to have an open circle at negative 5 and an open circle also because of this sign at negative 9. So an open circle at negative 5, an open circle at negative 9. So let's get the number line drawn. So now here's my number line. I've got open circles at negative 9 and at negative 5. So I'm going to start by choosing a number in this section. Let's say maybe negative 10. So I'll put negative 10 into the original problem. Negative 10 plus 1 over negative 10 plus 5. I'm trying to see, is that less than 2? On the top I have negative 9. On the bottom I have negative 5. And negative 9 divided by negative 5 is a positive 1.8. And 1.8 is less than 2. So we'd want to shade this part of the line. Okay, now we need to choose something that's in between here. So maybe negative 6. Again, it doesn't matter. You could do negative 7, negative 8. We're trying to see, is that less than 2? So on top I get negative 5. On the bottom I get negative 1. Negative 5 over negative 1 is 5. So this is no. We're going to leave that blank. Then finally, we'll choose something on this side. I like to use 0 whenever I can. So 0 plus 1 over 0 plus 5 would be 1/5. And 1/5 is less than 2, so we would shade this side. So now we just need to write that in interval notation. We read from the left, so we get negative infinity. And then we go to negative 9. Parenthesis, start at negative 5, and it goes to infinity, and put a U between them.